In today's video, we're going to be talking about torque. After watching this video, you should be able to know what torque is, use and apply the formula for torque, and then use and apply the formula for moment of inertia. So let's get right into the lesson. Just a quick review of Newton's first law. Remember, Newton's first law says an object at rest stays at rest, an object in motion stays at motion unless acted upon by a unbalanced force. And so for something to undergo rotational motion, an unbalanced force has to be applied to the object. Okay, to basically make something to start moving in a rotational motion, an unbalanced force has to be applied. And then unbalanced force is torque. Okay, and that's the name of it. It's called torque. Torque is created by a force basically causing an object to rotate about its axis. Okay? So there's a formula for torque. The formula for torque is d times f times sine theta. Okay, so d stands for the distance from the axis of rotation. F stands for force, and sine theta is the angle at which you make between the force and the lever. So you can see in this wrench here, I have it as R, but that's really the same thing as D. So this is the distance from the point of rotation, which is right here, to the point that the force is being applied, is the D piece. The force itself is going to be measured in newtons, and then sine theta is this angle here at which the force is being applied. All right, so that is a formula for torque, and the units, or it's measured in Newton meters. Okay, so when you get your torque answer, it'll be newtons times meters. All right. So let's just do a little picture here, looking at kind of how this formula all shakes out in terms of some things that I think you guys would be pretty familiar with. Let's take a look at a door. And again, I am not a beautiful artist here, but here's a door, and here's the hinges on the door. Okay, now if you were to say go into this door, or you were to put a doorknob on it, let's say you're a carpenter. If you put the doorknob here, think about how challenging it would be to open the door if you were to push on this door and the hinges are on the left-hand side of it. As you move the doorknob further away from the hinges, the door gets to be easier and easier to open. And I encourage you, if you're at home, to try doing this. Push on your door really close to the hinges, and then try pushing on it in the middle, and then try pushing out where most people install doorknobs, which is relatively far away from the hinges. So you can see the D piece here. As the distance increases from the axis of rotation, you get more torque, and more torque makes it easier to basically cause an object to rotate. Okay, so that's the D piece. Now let's look at sine theta. I think most people get force. I mean, the more force you apply, the more torque you probably have, right? But sine theta can be a little bit confusing. And again, I am not an artist, but I'm going to try to draw a wrench here, and I wish myself luck. But this is a wrench, and well, it's not actually bad. Basically, this wrench is trying to move this bolt or whatever in here, okay? And let's say I want to make this wrench move in this direction, okay? I'm going to try to spin it around in that direction, okay? At what angle would be best for me to apply my force? Well, I think most of you know that, I'd probably want to apply my force directly perpendicular to the wrench itself, okay? And that would be sine of 90 degrees, which turns out to be 1. Okay, so you're getting the most impact for the angle at which you apply your force. Let's say you try applying your force at like an angle like this. Now you're going to have less torque, okay? Now I encourage you to try this too. Try applying a force directly parallel with the wrench. Will you cause this wrench to rotate at all? And the answer is no. And the reason why is if you take sine of 0 degrees, it is 0. And if you take, you can apply all the force you want to this bolt here. Anything times 0 is going to be 0. You have no torque. You're going to have no rotation. So the formula, even though it may seem a little maybe confusing at first, it really actually makes a lot of sense once you get going and kind of think about what it's actually saying. So let's do an example problem using this formula. And remember, torque, which the symbol for torque is tau. It's a Greek letter tau. So torque equals force times distance times sine theta. And you can kind of put in whatever order you want. So if you want to put distance first or force first or sine theta first, it doesn't really matter. It all comes out to be the same. So as a pirate captain takes the helm and turns the wheel of his ship by applying a force of 20 newtons to a wheel spoke. If he applies a force at a radius of 0.2 meters from the axis of rotation at an angle of 80 degrees to the line of action, what torque does he apply to the wheel? Okay, that's a great question. So let's plug in what we know. All right, the force is 20 newtons. The distance away that this pirate is, or it's a cat, yeah, it's a pirate, okay. This pirate is applying from the axis of rotation is 0.2 meters, 0.2 meters. And the angle at which the action is being applied is at an angle of sine 80 degrees, okay? And if you plug all that into your calculator, you should get a torque of about 3.9 Newton meters. Right? And that would be the torque that this pirate captain is applying to this wheel. Okay, so there's an example of kind of how you can, That takes care of this video. I will see you guys next time.